Hi everybody, today we're learning about understanding angles. So up until now we've been dealing with acute angles and some obtuse angles. But all the angles we've been dealing with are under 180 degrees. So what happens when you have angles larger than that? How do you find the sine, cosine, tan of those, or the inverse sine, cosine, tan of those? So that's what we're talking about today. So for just a little exercise, take out your calculator, like actually do it, get out your calculator, okay, and put in sine 30 degrees. Okay, you should get 0.5. Okay, now try sine of 150 degrees. Also 0.5. Now, why would both of those give the same sine value? Now try sine 210 degrees. Okay, this is interesting. It's negative 0.5. You've never seen a negative sine ratio before. And sine of 330 degrees, put that in. It's also negative 0.5. So what qualities do these numbers share that would make sense for them to all have a value of either 0.5 or negative 0.5? So think about that for a second. 30, 150, 210, and 330. Well, we're going to be learning about drawing angles on the Cartesian plane, okay? So starting here as the base and then working your way around the Cartesian plane in this direction. Okay, so 30 degrees would be right here. Okay, from here to here is 30 degrees. Okay? 150 degrees, it's bigger than 90, but smaller than 180, so it would be here. This would be 150 degrees. Okay, so you'll notice that 150 degrees is also 30 degrees away from 180. That's interesting. Maybe that has something to do with it. And I'll draw these separately just so it doesn't get too muddled up here. 210 degrees, so that's going all the way around to 180 and then 30 more. So 210 degrees would be here. Okay, and 330 degrees isn't quite a full circle, but it's 30 degrees less than a full 360 degrees. So this was 210. And then this would be 330 degrees. Sorry, 30 degrees. So you'll notice that 210 is 30 degrees away from 180. And 330 degrees is also 30 degrees away from being a full 360. So 30, 30, 30, 30. Okay? They all share what's called a related acute angle of 30 degrees. So when they're drawn on the Cartesian plane like this, as we're about to learn how to do, they are all 30 away from the closest x-axis. And that's called a related acute angle. When angles have the same related acute angle, they will have the same sine, cos, and tan ratios. It's just that they might be positive or they might be negative, but the value will be the same. All right, so that's just a little preamble to get you all excited and ready for what we're learning today. Just need my cloth, just a second. So first we need to start with some definitions about how to actually talk about angles on the Cartesian plane. Okay? So an angle is formed when a ray is rotated about a fixed point called the vertex. So this is the vertex, here's the angle theta, okay? It's rotated from this initial arm, which is the start, and it's rotated through the terminal arm, which is the end. We can represent angles on the Cartesian plane. So the Cartesian plane just means the x and the y-axis. In standard position, the initial arm is on the positive x-axis, and the vertex is 0, 0. So that means that we start here. This is our initial arm. Okay? And then we rotate a certain amount of time to where our terminal arm is, okay? The terminal arm can be anywhere. In this case, I just drew it here. So we rotate in this direction. So this is theta. Okay, this would be called the terminal arm. And it can be anywhere. And this is the vertex, okay? The origin is the vertex. Okay, so this description is very important, all right? Now, a positive angle starts, right here. Again, you always have your initial arm here. A positive angle goes counterclockwise. So it starts on X and it goes in this direction. So it could end here, for instance. That could be theta equals 200 degrees. Okay, as an example. You can also have a negative angle. So you could have the initial arm and then the terminal arm in that exact same spot. But negative angle goes clockwise. So you would go this way. Okay, so if the arrow goes this way, then this theta is a negative angle. So that would be negative 160 degrees. Okay? So positive angles, which is going to be most angles we're dealing with, start here on the x-axis and they rotate counterclockwise. If you rotate in the clockwise direction, that would be a negative angle. Okay, so the Cartesian plane is divided into 4 quadrants. Okay, so we start here. This is 1, if you remember, back from grade school. This is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. Okay, so if you start here, the initial arm is always here, then that would be 0 degrees. Okay, once your terminal arm is here, that's 90 degrees. If your terminal arm is here, that's 180 degrees, right? A straight line. And then rotating another 90, this would be 270 degrees. And then back to the original, you would have gone a full 360 degrees around the circle. Now, this continues. You can keep going around and around and around and keep adding on top of 360. So if you went all the way around once and then here again, you would be at 360 plus 90, which is 450 degrees, for instance. And you could just keep going around and around for all time. So, but if you're just looking at the first 360 degrees, then in this quadrant, all the theta will be between 0 and 90 degrees. In this quadrant, the theta will be between 90 and 180. In this quadrant, between 180 and 270. And finally, in the fourth quadrant, between 270 degrees and 360 degrees. Okay, remember that's just for the first movement one time around. It doesn't consider when you keep going. Okay? So if x, y is a point on the terminal arm, we can have things like this. So if, for example, you have an arm that terminates in quadrant 2. Let's say this is called theta 1. I show the arrow to indicate that this is a positive angle. This means that theta would be between 90 degrees and 180 degrees. Okay, and we can say that theta 1 terminates in quadrant 2. Okay, that's the language we would use. Theta 1 terminates in quadrant 2. And we could draw a point anywhere on that terminal arm and label it x, y. And in this quadrant, the x would be negative, since we're going in the negative direction for x, and and the y would be positive. Okay, so now we're going to do the same things for quadrant 3 and for quadrant 4. So for quadrant 3, your theta then would be between, you would say theta 2 terminates in quadrant 3. Okay, and you could draw a point anywhere, label it x, y, and in this quadrant, your x is negative and your y is negative, your x value and your y value. Finally, in quadrant 4, here's our theta 3, okay, and a point anywhere on the terminal arm. So here we say theta 3 terminates in quadrant 4. Okay, and your x is positive and your y is negative. Okay, so there we go. You could also, for instance, have something else if you drew another one. Let's say we wanted to draw exactly 270 degrees. Then that wouldn't be on any quadrant. That would be terminating on the y-axis like this. So in this case, theta would be equal to 270 degrees. And any point would be of the form 0, comma y, where y has to be negative. Because if theta is 270 degrees, it has to be on this y-axis, but on the negative part of the y-axis. So x has to be 0 and y has to be negative. Okay? If y was positive, then it would be up here, and then your theta would be 90 degrees. All right, so on the back, we're going to get ready for some important definitions. Get excited. Okay. So coterminal angles, this is your first important definition. Coterminal angles share the same initial arm and terminal arm. Okay, so they look the same is really what the deal is. So before we get to the rest of that, let's just draw a set of coterminal angles. So they all have the same initial arm. Ooh, that's really not looking straight. The same initial arm, okay, always on the x-axis, the positive x-axis. And let's make it about here, okay? So do your best to replicate that exact same angle on all 4 of these little Cartesian planes. Okay, so all these angles right now look the same, but really there are an infinite number of coterminal angles that can be represented by this picture. Okay, so first of all, we can talk about the principal angle. The principal angle is between 0 and 360 degrees, and it's positive, the first positive angle. So that would be if I start here, and just the first time I hit it, that's going to be 120 degrees, let's say. So that is the principal angle. All right? Now, we can come up with all kind of coterminal angles positive coterminal angles by just keeping going around the circle. So if we add another multiple of 360 degrees, we can find another coterminal angle that's positive. So we draw that by starting here. We go all the way around, we hit it, but we keep going, go around again, until we hit it, and we draw the arrow to show it stops. So it's gone around the circle once, and then all the way to this. So this positive is 360 degrees, which is the first circle around, plus the 120. So you get 480 degrees. So if you were to draw 480 degrees, you would have to go all the way around once to 360, and then add another 120, which would end up in quadrant 2, since it's between 90 and 180. Okay, now you can go around more than once. You can go around 3 times, 4 times, 5 times if you want. So in this case, I'm going to go around, I'm going to start here, go around once, go around twice, and So in this case, theta 3, I had two full revolutions, so that's how I get the 2 times 360, plus the 120. So that gives me 840 degrees. Okay, so I end up in this quadrant because 840 is twice around 360, and then I have 120 degrees left. So that's between 90 and 180, so it ends in quadrant 2. It terminates in quadrant 2. Now, I can also find a negative coterminal angle by going in the opposite direction, right? By going clockwise. So in this case, how would we find that? Well, we know that this from here to here is 120. So in this direction, it has to be negative of 360 degrees minus 120. Because all the way around is 360, but the 120 has already been taken out. And it's a negative angle, that's why you need the negative there. So you get negative 240 degrees.